components of the machine. On this little video, I'm just going to show you how to square a board. Having measured our image, worked out how wide our margin and how wide our mount's going to be, we've worked out our overall mount board size, and now we need to cut the board to size. It's a good idea, even with new board, to square it properly. You can't trust it's going to be perfectly square from the start. So basically we need to make 3 cuts. This is a piece of board just bigger than we actually need. I'm going to mark on the board to show you where we're going. First we have one straight edge. That's basically our datum side. And the first thing we're going to do, so I do this even with brand new board, is just to take a sliver off the end, so 1/4 of an inch, 10mm, and basically we've just cut this side, so now we know that corner is 90 degrees, and that's our second one. And then the next 2 cuts will be 2 sides. So I'm going to do it 10 by 12 or 30 by 25 centimetres. So that is number 3, and we've just squared that corner. Reset the scale. And now we've cut that one. That is square, and because that was our datum, that one is all square as well. So now that is all square and good to go. What we're going to do here is set the machine up for dining out any under or overcuts. The first thing we need is a squared board, and what we're going to do is set the machine up. I'm setting this to 8 centimetres or 3 inches, just making sure everything is set to the same. Put the board into the corner hard up against the mat guide on the bottom edge. We bring the cutting head down on the finger gauge, engage that just on the edge of the mount board, push the blade in and pull. Turn the board through 90 degrees and make a second cut. And what we've done is cut one corner. What we have here is a slight overcut here and a slight undercut here. This one isn't quite reaching the corner, and this one has gone past the corner. So what we need to do is first I'll start with this one, which is an overcut, and you have to work out where it is on the machine. When it's in the machine, we're cutting this line, and the start of the cut is overcutting, and on the micro adjusters we can dial this out. So it's overcutting, so the cut is too long, so we need to reduce the length of the cut, and this is about 1.5 millimeters, so I need to reduce it by 1.5 millimeters. And the important thing is to remember to reset the gauge to the right dimension, because if you don't reset it, you haven't actually altered it at all. And then on this cut, this is undercutting, so we need to extend the cut, so we turn that to the plus. Again, this one's about 1 millimeter, so we adjust that and reset. Then in the corner that we haven't cut, again, make 2 cuts. this was our cut. We've still got a slight overcut, so we need to reduce the cut. So just a little. And reset. Now what I'm actually going to do is reset this to 7 centimetres all the way around. And we can use the same ball. Just do a quick check. And typical, I've taken it too far back, so I just need to go back. Extend the cut because it's slightly undercutting, and reset. And what I'm going to do is carry on round. And there we go, the machine is now set up, no under or overcuts. What I was going to show you here is just how to cut a simple mount, that's with margins even all the way around the mount. We've already worked out what the size of the mount is, and we've squared the board, so we're just ready to cut the window. What I'm going to do is cut a window that has a mount margins 75mm, 3 inches all the way around. So we set the margin arm 75mm. This is the start of the cut, so we're setting that one to 75 as well. And the bottom of the cut there, that's 75. Just a quick check to make sure everything is 75. Then we take our mount or our mat, cutting face down into the slip, against the margin board and down against the bottom of the machine, so it's into the corner. Bring the cutting head down, we press the finger gauge here down until it's resting on the edge of the mount, and then we push the blade in. As the blade goes in, there's a tendency to push the cutting head away, so you need to keep a little bit of pressure on the finger gauge as you push the blade in. When the blade is fully down, release and cut to a bottom stop, then release the blade. And now it's just a case of rotating the ball round and repeat. Bring the gauge down onto the edge, blade in, release and complete the cut. The third cut, again in with the blade down, and the final cut What I'm going to show you here is how to cut a mount with a bias on the bottom. That's a slightly wider margin. It's a feature in mount cutting that I particularly like, and most of the mounts I cut, I have a little wider margin at the bottom. Then depending whether it's a portrait or landscape, normally I just mark a cross for a portrait mount on the bottom. But what I'm going to do here is actually write the dimensions down so it helps you keep track of what I'm doing. So we're going to use 75mm on the bottom, or about 3 inches, and we're going to do 70, 70 and 70 on the other 3 sides. And the method I'm going to show you is the easiest, quickest way of cutting this with a minimum number of stops. It's certainly the quickest way, and also the less number of times you're changing the stops gives you less chance of getting it wrong or moving the stop the wrong way. So I'm going to start with the widest margin, 75. on the mat guide there. I'm going to position the board in the machine, lower the arm down. The two sides need to be 70. So we set the start and finish stops at 70. Then we cut down with the finger gauge to the edge and cut. We now do the opposite side. This one is now 70, so we need to change this to 70. Having changed that, we never touch that one again. Into the bottom of the machine, lower the head. The two sides, they're still 70, 70, 70, so we don't need to change those. Down and cut. Now we've just turned it through 90 degrees. You can go either way around, it doesn't matter, but I prefer to bring the wider margin down to the bottom, lower the cutting head. 70, I say, we don't need to use that. We have 70 here, but we need 75 at the bottom. So we now move bottom stop to 75, double check 70, 70, 75 and cut. And now for the final cut, turn it through 90. Lower the head. So this is the final cut. This is the only time we need to change two of the stops. This one was 75, we need to take that back to 70. And this one, our wide margin wants to go to 75. And cut. And then we have the portrait mount with a bias on the bottom. forgetting the bit in the middle. Then we place our bottom mat, making sure it's within the confines of the top mount. We don't want any bit outside the top mount. Now when we cut the window on the top mount, we used the top mount as the registration, and basically we used the same mount as the registration for the bottom mount. So basically it's got to be parallel. We can now go around, change all the stops to the required width, which in this case is 60 millimeters. Six, double check, and then we go around and cut again. Remember, when you bring the finger gauge down, that you're registering on the bottom mount, not the top mount. And cut. And then we have a double mount with perfectly parallel lines, and what's more, the mount is already stuck together, so you don't have to do any sticking, it's all ready to be mounted. What I'm going to show you in this demonstration is how to cut a window mount with a title box. You can do most of the cutting with the stops on the machine, but when we start talking about larger mounts, you have to start drawing freehand because you go off the scale of the gauges on the machine. So this is what we're going to produce. Worked out our window, a 20 by 60 millimeter title box in the centre at the bottom. What we actually have here is 50 millimeters on the sides, 60 on the bottom, with our title box in the middle. The first thing I'm going to do is draw out where the title box is going to go. Now we can use the mount cutter as a drawing board, and we do our marking out on the machine. So the bottom of the title box is 20 millimeters from the bottom. I use the pencil at a bit of an angle because the blade cuts about a millimeter from the edge. So if you draw it directly on the edge, you're going to be slightly out when it comes to cutting. So I just use the pencil, propelling pencil, because you don't want to get too much lead on the edge of the blade either. So draw a line. Title box is 20 millimeters deep, so I've just extended it to 40, which gives us the 20 plus the 20. And I've worked out to give us a 60 millimeter box in the middle, we need to come in 95 millimeters from the edge. So I've set it to 95 millimeters. And I'm going to do a long pencil line because it just makes it much more accurate when we come to do the cut. And there we've marked out our title box. The bit we're going to cut out, I'm going to put a cross. And that's the bit that's going to fall out. The other thing I like to mark is the corners, where we're starting and stopping. When it comes to cutting, the tricky one is the top of the title box. It's not so bad with this size of board, with larger boards we go off the scale. So I'm going to cut all this freehand, not using the stops on the machine. Just going to back the mat guide off. And I'm going to start with the bottom. When you're cutting, the cross, the piece you want to fall out, must be under the cutting bar. if you can see it, your bevel's going to be going the wrong way. So I'm just lining up the pencil line with the edge of the cutting bar, and I've got about a millimetre gap there, again because the blade is cutting slightly away from the... You can just touch the blade on the pencil line just to check it's in the right position. Now, because we're not using the stops, there's two ways of cutting. You can use the finger guide, or there is a little notch on the side of the cartridge that holds the blade. You can use either as a guide. When you're cutting without using the stops, you can use the finger gauge. When I was doing some test cuts, and it's well worth doing a little bit of practice just to find out where it's slightly under or over cutting. On the start of the cut, I found it was slightly over cutting, and on the finish, slightly undercutting. So using the finger gauge, because it's over cutting, I'm going to come about 2 millimeters past the line, push the blade in, and because it was undercutting, I'm going to take the gauge about 2 millimeters past. And then we go round. Again, just checking the blades on the line. Starting just past the mark. And just coming past with the finger gauge. Always making sure the bit that's going to fall out is under the cutting arm. Again, just past the line, and then just going past the line. And the last cut. It's nearly there, it's slightly undercutting. It's always better to slightly undercut than overcut. If you just need to cut the last little bit, if you get a blade, you don't need any pressure. Just let the bevel take the angle and just pull it into the corner. And we do the same. And then just go around the corners. Just pull it gently into the corner. That one was good, that didn't need doing. So you don't need any pressure, and you let the bevel take the angle. There we go. And there's the title box cut. And then we just cut the window as we would normally. In this video, I was just going to go through the various blade options and what the various blades and when you may use the different blades. We have a table which is in the notes with this video, and it should be on the screen, just showing the basic details of when and where you should be using the blades. It's a rough guide showing from a soft to a tougher, more dense board, from a thin to a higher board, and it just gives an indication as to which blade you should be using where. There are basically 4 blades, 2 thicknesses and 2 cutting styles. Here we have the Tech D12. The D is for double-sided, so we have a bevel on both sides of the blade, and the 12 is the thickness, 0.12, that is 12 thousandths of an inch, or about 0.3 of a millimetre. Next to that is the same thickness blade, so it's a 12 blade, but it's a Tech S, which is a single-edged blade. So that just has the chamfer on one side, and it's flat on the back of the blade. Next we have the Tech D15. D, again, double-sided blade, but this is a 15 or 0.15, 15 thousandths of an inch, slightly thicker. So we have a slightly thinner blade and a thicker blade. with the double edge. And then to finish the set, we have the Tech S15, which is the 15,000th, the slightly thicker one, again with the single edge. So we have one chamfer and one straight edge on the back. The thinner blade, the 12, that will give you a cleaner cut. It's easier to use, so you're trying to part less material when you're cutting the board. The 15, slightly more rigid, but again it takes a little more effort and doesn't give quite such a fine cut because it's a bit thicker. But obviously if you're cutting tougher material, that would probably be the one to go for. How we choose which blade to use is going to depend on what material we're cutting. Mount board comes in lots of different thicknesses and lots of different materials, from a standard board through to conservation, through to a museum grade rag mat board. Most board we're cutting is going to be a standard 4-ply, around 1.5 millimeters, 1/16 of an inch thick. In that case, I'd be using the thinner blade. This is the Tech 12D. This is good all-round blade. It gives you a fine cut and is certainly excellent for standard board. As boards get thicker or denser, you might find you start getting a hooking effect, which is where the blade is being deflected at the start of the cut, and then as you start cutting it straightens out, giving this sort of hook at the start. To prevent that, the next step is usually to go for the single edge blade. This changes just the characteristics of the way the blade parts the board and enters the board and runs when it's cutting. There's a little arrow pointing at which end of the blade to use, because with it being a single edge you can only use it one way round. The double edge, once you've blunted one end, you can turn it round and use the other end. You can't do that with a single blade, it's a single use, one end only. As materials start getting thicker, you may need a slightly more rigid blade, which is when we go up to the 15, slightly thicker blade. And again, it's like going back to the 12 blade. You probably start with the D15. If you start getting a problem there, then we go up to the S15. There's a lot of overlap. You can probably be using 2 or even 3 of these blades on any of these materials and they'll cut perfectly fine. But I would generally say the thinner blade, the 12th thou, using that up to about 3 millimeters. So with your thinner, softer boards, certainly the D12. As you go up, sort of the density or the toughness of the board, so maybe going up to a rag mat or a conservation board, you may need to find that you'll need to go to the single edge. As you get up to 3 millimeters or over 3 millimeters, that's when you probably start using the 15 blade. Again, starting with the double edge and progressing onto the single edge. There's a lot of trial and error because there's a lot of differences in thickness, even standard boards between different manufacturers. The actual depth can vary slightly, and the density of the board, particularly from cheaper, thinner boards, even though it may be described as a standard board, up to a conservation rag mat board. The blade I use most often, most of the board I'm cutting is a standard thickness, so about a 1/16, 1.5 millimeter board, and my standard blade is the Tech D12. Thinner blade gives the finest cut, better quality cut. Being double-edged, it means you can use it twice, so basically you get twice as much usage out of this as you would with a single-edge blade. If I'm doing things like V-grooves or start cutting, say, 2.5 millimeter board, I'd probably be thinking about using the Tech S12. Certainly for V-grooves, that is very good for cutting the reverse bevel on a V-groove. You don't need to use any spacers or anything, you can cut it straight with the 12. I don't do very much cutting over 3mm, so I rarely use the 15 size. So generally for my all-round blade it's the Tech D12, and then when things start getting a bit thicker I'm going up to the Tech S12, and certainly that's good enough for 3mm. I personally rarely cut anything over 3mm. Also, if you want to go into a bit more detail to understand the engineering and sort of technicalities of how a blade cuts into the board, there will be some more detailed notes in the description that's alongside this video. Here we have the Keencut Excalibur 5000. Use it for cutting all sorts of sheet material. Quickly go around the machine. The main part is the vertical section here with the cutting heads. The horizontal section here where you place your materials, and the legs which form the A-frame and support the main parts of the machine. On the vertical section here we have a clamping arm. This works in a vertical or perpendicular motion, so it doesn't move the material while you're clamping it. The top cutting head here has two rotary metal blades for cutting MDF. There's also a counterweight here, which usually use it on the upper cutting head, but you can also attach it to the lower one, particularly if you're doing a lot of repetitive cutting. But that sits at the top there. Out the way there's also a locking screw on the side if you need it. The lower cutting head here, again there's a locking screw on the side. The main cutting turret in here, I'll just take the cover off. There are three cutting functions on here. Very positive, easy locking mechanism. There are indicators on the back here so you can tell which of the functions is engaged, and there's a little window in the cover here so you can see it. The cutting blade here, this is for cutting mount board, foam core, corrugated backing board, that sort of thing. Is a standard utility trapezoid blade, and there are metal clamps here which you can move in and out to prevent flexing, especially when you're cutting deeper material. Here we have the scoring blade, which is the same blade as the cutting blade, but as it's a scorer we use it upside down. This is for plastic sheet, acrylic, styrene, that sort of thing. And finally on here we have the glass cutting blade, or the glass cutter. This is for typically 2 to 3mm sheet glass, but you can also cut up to 6mm for sort of mirrors and things like that. Just tighten that up there. Also on the top here we have a ratchet. If you're cutting deep material and you want to do several cuts, you can set the blade at different depths, or you can release it, or if you don't need that function, you can just lock it out of the way and the blade, just or whatever you're using, just go straight in and out. Put that to the bottom. Down here we have the horizontal arm. This has a steel runner in the bottom to prevent any wear, particularly from glass. And there are two measuring stops, so you can set your width and height, and you don't have to change the dimensions between cutting. These slide, and they also rotate out the way if you've got large sheets of material. You can lock them up and they slide in and out the way as required. And finally we have the supporting legs, which are telescopic, so you can adjust the height of the machine depending on the materials you're using. Personally I prefer mine at about this height, so I'm not bending down too much, but if you're using a lot of oversized sheet material you might want it lower so you're not having to lift it so far. It makes it easier for loading on the machine. Or as in this case, we've got a fairly low ceiling height, so we need to lower the machine down to be able to fit it in. To demonstrate cutting the materials, we set this to 20 centimetres or about 8 inches, and this one to 30 centimetres or about 12 inches. We'll cut some MDF. So into the machine and clamp, and just pull head straight down to the bottom. Scrap. Rotate it round, engage that one, and that is the first one cut. Now if we do some mount board, again, just going to take that out of the way, up to the stop clamp. This time we want the blade for cutting. That's the glass. That's the blade for cutting engaged. So in we go and down. And finally, if we do the glass, and again we change to the glass cutting head, just engage just below the top edge. Out of the way. And there we go. And there we have all our materials, all cut to the same size and all perfectly square.